Hello and welcome to The Nature of Code. I'm going to be doing this series again. We're still going to be using Rust and we're still going to be using GGEZ, although we're going to see about using the latest versions. Now, I've done The Nature of Code before, and before I get too far into it, let's take a look at what The Nature of Code is. It's a book by Daniel Shiffman, who runs the wonderful YouTube channel, The Coding Train. So I highly recommend, if you haven't heard of him, head on over to The Coding Train. I'll have a link down below in the description, and give him a follow and take a look at some of the stuff that he's doing. He's actually going through and creating the examples from this book in processing. And in fact, this book is made in processing. So all the examples will be there. Now, processing is a language that runs on the JVM. It's very similar to Java. There's also a P5.js, which is essentially processing, but for JavaScript. And I really like Rust and GGEZ. So what I wanted to do was do these exercises, reread the book. I previously got around a quarter of the way through. And if I reread the book, do these exercises in GGEZ, and it's a way of like learning animations, learning, nature coding and artistic coding, and maybe it's sort of like continue my exploration and learning with Rust as well. And if you end up following along with me, let me show you what version of Rust that I have. If we do a Rust up version, we'll see that I am on Rust up version 1.23.1, which has I'm using Rust version 1.47.0. So the latest possible for that. And then we'll get into what versions of like GGEZ that I use for each of the examples. Okay, so here's how they're all going to work. I'm going to, inside of this repository, which again, I'll have a link down below in the description, I'll have, I'm going to be creating a new app for each of the examples and potentially each of the challenges. It really depends upon whether or not those challenges make good videos or if they're really like worthy of making apps for. I'm sort of going to play it by ear. So the first one we're going to do is example I.1, which is the traditional random walk. And if we actually come over to this website, you can read this for free or you can pay for it. I actually have a physical copy of this book that I'm going through. I have it sort of sitting on a reading display to my left. And we're going to go to introduction, and I'm going to skip all the reading parts. And here's the first example. This is what we want to make right now. So let's go ahead and get started. Do a cargo new, and we're going to create, this is going to be, we call this I.1, traditional random walk. Create that binary application. I don't need to, well, might as well CD into it. In fact, you know what I'm going to do? I'm going to reopen VS Code inside of that file. To open up you. Oh, I need to open up a Windows. To do, what is this? Nature of code in Rust. I.1 traditional walk, open up code here. I am on a Windows machine, and while it is possible to run Rust inside of a WSL or WSL2 container virtualization, it's GGEZ and like graphics programming is not really the best experience. All right, so here we have our folder structure here. We're going to go ahead and get started setting ourselves up. So first of all, I'm going to pull in cargo add GGEZ. I'm using cargo add or cargo edit. I can never remember the name of the tool, the cargo tool, and that allows me to do a cargo add, and that gives me the latest stable release, which is 0.51. All right, so I've got that, and let's go ahead and get ourselves going. So we know that the first thing that we need to do, and actually if we go and look at the GGEZ documentation, sure, just go to that, back here, here's 0.51. So we need to pull in all of this stuff. So I'm not going to worry about this. I'm using Rust Analyzer behind the scenes, and it's going to help me pull all of these things in as I need them. So in function main, okay, so we need to create a context and an event loop out of our context builder. And I think I'm going to make it maybe a slightly bigger too, potentially. Yeah, we'll just keep it the basics right away. So we're going to use context builder new. All right, so let's, it's going to be this mute context and event loop. We're going to have a context and event loop. They do need to be mutable, but I can actually do this here at this point. And then we're going to pull this out of the context builder. Right. Before I can pull anything like this in, because I did use the cargo add command, I do have to tell Rust Analyzer to restart. That way it will reread the cargo.toml file and refigure out like what libraries are actually available to me. So once it's finished fetching the metadata, I do have the latest Rust Analyzer installed, and it's updated yesterday or this morning. So the absolute latest as of, let's see, what is it? March 2nd, 2021. Can I pull you in yet? Is thinking about it. No, not yet. It's still running this cargo check down here. There it goes. Okay, so now I can import. Maybe. There it goes. Now I can import that. That pulls in the context builder. We'll do new. And then what else do we need out of here? So new, we need to give it. I'm surprised you didn't properly tell me what you need. New. Okay, so what are you going to be? You're going to be the name of the game and then my name. So this is going to be traditional random walk and Brooks builds. Then I think it's just .build and then .unwrap. All right. Do you what don't you like about this? Is it that? What are you upset about? Expected an item. Wait, did I not do this in main? I forgot to do it. In main. That's where you go, in main. Okay, so now I can re-put you in here. And so each of these are now going to be a mutable reference to the context and the event loop. Nothing else needs to be done with it. Perfect. Okay, so now that I have a context and an event loop, I need to create my game, and it needs to extend the event handler. So let's go ahead and create a live.rs. And inside of here, we're going to have a hub struct. This is going to be our just gonna have like this be the game state, or maybe like the main state, because it's not really a game. I'm not gonna put anything in there, but we do now have to import the event handler for main state. And we're going to implement the missing members. There are actually more methods than these, but we don't need to do them. The update and the draw are the only ones that we absolutely must do. Okay, I like to rename these as context. We don't necessarily need the context here. And let's see, all that brought in. Context. You're fine here. Let's go ahead. We're going to set a background for this. So we're going to do a graphics clear. And you know what? Now that I think about it, we probably don't need to clear, because if we take a look at the example that we have here, it's just drawing and sort of continuously overriding it. So we don't actually want to clear it every single frame. So instead we're going to use graphics present. Hand it this context, and it returns this result, which happens to match up with here. So we're good to go. So now I can take this main state, pull it in here. And I actually like to use a constructor sort of pattern for this. So impl main state, pub function new. We're going to return a new self, which is the main state. And we're going to just do self like that. And then in main, right, let's, I cannot remember if you need to be mutable. Yeah, I think you do. Maybe not. I don't know. Let's just not make it mutable, and it will yell at us if we do need it to be. Or we can check the documentation. That also works. We do need it to be mutable. Okay. Here we go. Let mute. This is going to be main state is equal to main state. Pull that in. New. All right. That gives us this. And then we can, what's next? A match event run. So bring into context the event loop and our game, and then we'll have whether or not it works. So we're going to match event. I think it's just event run. Run. Okay, so pass it in this context, pass it in the event loop, and then the main state. Fill the match arms. Okay, so if things went okay, I don't think that there's anything that we really care about. No, not really. So in here, we're going to print line. Exited cleanly. Have a nice day. However, if we error, we're actually going to get the error object, which is this game error, and we can debug this essentially. So we can do an ePrint line, which prints to standard error. We're going to say error running the simulation. We could even print this out because error should implement display, and we'll display the error. Then I don't need that hello world. So, okay, mismatch types. A mutable reference is what we need here. So add that in. We only have warnings now, no errors. Let's go ahead and take care of these. So I don't need. Oh, I don't need presence because off of that. I don't even think I need self. I don't know why that's in there. Let's see. You are complaining because, oh, I should consider implementing a default. A default should be pretty simple in this case. I'm going to do a derive and then default. What this allows me to do here is I don't even have to do the self. I could just do a self default. And that will return for me now. Okay. Don't need this run. So let's go ahead and get rid of that. No more errors. Let's go ahead and open the terminal and we're going to do a cargo run. We do have to compile everything at this point in time, but it should be pretty fast because I'm not streaming at the same time. And that takes up so much processing power, but now it's even faster. And I am on a nice beefy desktop, so it's really fast here. Compiling in Rust is really nice because it is using a bunch of threads to do the compilations. All right, so we got a error. What happened? 15, library line 15. Not yet implemented. What of mine did I, oh, to do. That's a problem. I can't have a to do in there. I do have to return a game result, so I'm just going to return an okay like that. Let's try this again. There you go. So here's our lovely window. Let's go ahead and now actually build this entire thing. So the idea about this example is we're doing a traditional random walk. We're going to create now in processing, we'd create a class named a walker. So there's no classes in Rust. It's not an object-oriented language, but there's a lot of things that are very similar to an object-oriented language. So I'm going to go ahead and create a walker.rs file. And in the main library, we're going to mod walker. And we can now put stuff in here. So we're going to do a pub struct walker, which is it's the equivalent of a class, if there could be one inside of Rust. And we're now able to say, like, what is this going to be? It looks like we need a X and a Y. Yeah, we just need an X and a Y. And they're going to be F32s, so 32-bit floating point numbers. So X, and I think we're going to need to make these public as well. 32, pub Y, 32. Now the reason for that is because we need to make them, we need to get this out when we draw it. Now, is that true? Maybe not. Because like I see so we actually don't need that now that I think about it, because looking forward, it actually suggests that we need a display function. Oh, and we also need a constructor. So constructors we saw pretty easy. We're going to import walker function new. And we want to set this to be like the halfway point. Let's actually for this take in an X, and we're going to tell it where to be when we initialize this walker. So F32 and a Y, which is an F32. We're going to return a self. So we're going to return a self with an X and a Y. In Rust, if it would just be something like X:X, then we can just go ahead and leave that off and just have it be X. It's a nice little bit of syntactic sugar that makes it for a little bit less typing. Okay, so that gives us a new here. It's also telling us that we've never actually constructed this walker. Something else that's saying we need a display. So we need the ability to display this to the screen. So let's go ahead and add another method in here. So pub function display. Now, in order to make it work with and actually get access to these, we need a self. It is just a reference to self, so I can't mutate anything. It's going to be read only. I also see that it's going to be like a stroke and a point. Okay, so actually draw it to the screen. So that means we need to have the context, which is the GGEZ context. And if we're going to do that, then we're also going to need to return a game result. All right, so how is this going to be? It looks like they're making this either like just pure white or pure black, but depending upon our background, we have a black background, so I'm going to make it white. It's also just a point, but we can use as a really tiny circle. Now, because of that, we need to create a mesh in order to do that. So let's go ahead and create the mesh here. So mesh is equal to, and thinking about it, we don't want to have to create this mesh every single frame. Let's actually create that in here. So I'm going to have the walker store its mesh. It's going to be a type mesh here. But when I create that, that means I need the context in here too. So I can do let mesh is equal to, do a mesh builder, new. We're going to create a circle. Okay, so we're going to have a draw mode. We're going to fill it. Okay, so where exactly is this going to be? It's going to be, we're going to put it at 0, 0, and I'm going to translate it over to where it actually is for real. Okay, so then radius, let's make this like size 1.0 and a tolerance, which radius, that would be a 2 pixel diameter, which I think is going to be fine for this. Tolerance is 0.1. That's actually how circular the circle is going to be. If I make it a much larger, it will be more angular circle, if that makes sense. And we're going to use a white. Okay. Then we're going to build this, pass it in that context. And we do have to now, we're going to question mark this. We're going to return a game result with the self if it passes. That's what this question mark basically says. If it's going to be an error, return the error part of the game result. Otherwise, we're going to return the success, which will be this, okay, self, XY, and mesh, and close there. All right, so draw mode, we need to pull you in. Game result, you're not returning anything. Let's go ahead and just do an okay for right now to make you happy. And we're good to go here. So you notice I don't have a semicolon here. In Rust, if the very last line of any block, if there's no semicolon, it's an auto return statement. I could in fact write return here. If I were to do that, then I would absolutely need to have a semicolon. However, when I do that, it's telling me, hey, I don't need the return statement. Clippy, which is basically a linter for Rust, is yelling at me saying, hey, no, don't do this. This is a bad practice in Rust. All right, so we've got that here. We now have a mesh stored inside of here, which means we can now grab that out. So down here in display, we're gonna just draw it to the screen. So we're gonna do a graphics draw. Okay, first thing, we need a context. We have that passed in. The drawable, so it's gonna be a reference to self.mesh. And then any draw params. So draw param, new, and it gives it the default values, but I do want to send it to the appropriate destination. So we can do a dest. And now we give it like a point, like where do we want to go? So it's going to be the X and a Y. So self.x and self.y. And then I don't need a semicolon. Graphics draw actually returns a game result all on its own. So let's take a look at this line in its full glory. All right, what else do we have? We have a step. And if I wanted to wait and just like display this to screen right now, just to make sure that everything is working, come back to the main library. I do notice we're gonna have a problem because if I want to store the walker here, so if I want to say like, okay, walker comes in here, it's gonna be a type walker. That means I need to be able to create that, but that means I need to have a context here. And then we're going to need to return a game result with self inside. So we're going to have to go back to main and sort of fix that as well. All right, so let's go ahead and fix you. We can no longer derive default. So we're going to have to potentially implement that ourselves. Let's see if Clippy still yells at us about not implementing default now. All right, so what do we need to do? We need to create this walker. So that walker is equal to walker new. Let's give it just an arbitrary value like 50.0, 50.0. We're going to question mark this and semicolon so it handles that result that gives us this walker. And now we can return a self, not just self, an okay, self, and then the walker. Expected 3 arguments. Oh, right. The context is the last thing. So we can just pass the context straight on through. All right, so everything is happy here. We need to come back to main though, because we got an error here. We need to be able to, we got this game result. I want to be able to handle this. If things aren't working too well, let's go ahead and just cause an error. Now, something that's, I guess like I think of it as new, but it's actually not new. You could do this for a long time. We can have main return a game result. And so by doing that, when we do main state new, we can pass in the context. We can do a question mark here in main. This entire match event wrong, we don't need to do that anymore. We can just do event run and we just return the result of that and we're good to go. So main should be happy. We have 5 warnings, but no errors. Let's go ahead and run this. See if our dot is in the correct place. I don't see a white dot. I would expect like 50 over, 50 down would be like right around here somewhere. Oh, you know why? Because we never call it. We have to actually call the walker. So let's go ahead and do that. So in display here, we're going to do a self.walker. So self dot, oh, this is the wrong one. I need to be in the main library. Can do a self.walker.draw.display. Hand it the context and question mark semicolon. Now if I run this, there, a really, really tiny dot. I have no idea if you can see this. Let me check. Oh, that's too small for us to see. Let's go ahead. Let's actually make this a little bit bigger. So we're going to come into the walker class here, where we have this radius of 1. Let's try making this a 5. We're going to rerun this. There we go. That's a lot easier to see. Okay, so now that we have that, let's go ahead and let's put it into the very center. So we're already having to tell it exactly where to go. In GGEZ, to find the center of whatever the screen is, we can get the full coordinates, which is exactly like the width and the height that processing gives you. So we're going to do width, height equal to, there's a graphics drawable size. We pass it in the context, and that gives us an F32 of the width and the height. Now I can say width divided by 2.0 and height divided by 2.0. So if I do that, no other changes, we should be able to compile this and see, there we go. We have our walker in the exact middle of the screen. Okay, so then the next thing is we need a step method inside of walker. All right, so let's go ahead and add that. Pub function step. We need this to be immutable self because we're going to be updating the X and the Y. We don't necessarily need to return anything at all. So what's going to happen here? We need to get a random number between like essentially a 1, 2, a 0, 1, 2, or 3. That's actually going to be a little bit more difficult for us, isn't it? Rust doesn't actually come with a random number generator in the standard library. So we have to pull that in from a crate. So I'm going to do a cargo add rand. And we remember after we do that, we have to restart the server. Rand is going to allow us to just randomly generate a number. We can, there's a couple different ways we can do this. We can do an entire big, like randomly generate a, do something called like a gen range, which will give us a range very similar to what we have in the examples in the book. But I'm thinking if there's a method that I can call just right away. So I can do they call it like the choice. I want you to be an F32 equal to, I do have to give a type annotation for this, unlike most everywhere, so that rand knows exactly what it needs to do. So we can do random. And that should give us an F32 number. I can actually print this out using debug. Choice. That means that I need in update, we're going to call self.walker.step. And when I run this, we should now see what those random numbers are. Here we go. They're numbers between 0 and 1. So an easy trick for dealing with this is I can now multiply this by whatever like my range is. So I want it to be 4, I think. If I do that, we should be able to see numbers between 0 and 3, like not coming all the way up to 4. Oh, you can't multiply by 4. It has to be 4.0 to turn it into an F32. And what are you upset about? Oh, type annotation. Oh, it can't figure it out anymore. Okay, fine. I'll give it the type right here, F32. That means I no longer need this type annotation. It'll figure that out for me. Okay, so cargo run, and if we close this, we can see we have 0, 1 dot, 2 dot, 3 dot, but never a 4. So if I floor this, so if I take this entire choice, can I floor? There we go. And if we run this again, we should have, yeah, exactly. We're going to have like 0.0, 1.0, 2.0, 3.0. Okay, perfect. So now I can actually, I wonder if I can like also convert this to just a full integer. I floor it first so I know exactly what's going to happen to it. I'm going to say, I want you to be an I32. If I do that, then this will look exactly the same, but now no decimal points. It's exactly what we want it to be. We can actually do this all together right here. So we're going to parenthesize these. Then we're going to floor this and as an I32. That gives us the choice here. Okay, now we're going to use some if statements here. So if choice is 0, else if choice is 1, else if, you know, in Rust we have like the equivalent of a switch statement. We saw a little bit of it before I removed it. We can do a match off of choice. So we can say, okay, if we have a 0, then what do we want to have happen? And here we want to move to the right. So we're going to say self.x plus equals to 1. Notice I don't do plus plus because that doesn't exist in Rust. We can't do that. Okay, 1. When we have a 1, I want to run self dot. This one is moving to the left. So x minus equals 1. And then we're going to have 2 self dot y plus equals to 1. 3 self dot y minus equals to 1. Can I assign this? What's our problem? Oh, because they're F32s. So I need to convert all these into F32s here. And I do that with just the 1.0. All right, so match.choice, non-exhaustive patterns. Well, it's saying, hey, we know that choice is going to be an I32. We know that it can only be 0 through 0, 1, 2, or 3, but the compiler doesn't know. So I'm going to go ahead and say, hey, if it's anything else, I'm actually going to use something called unreachable. This will actually crash if it reaches here. But I'm telling the compiler and other programmers who look at this could never happen. Or at least it should never happen. Okay, so if we step here, at this point in time, it should work now. Let's go ahead and cargo run this. And now we have a random walker running around the arena. And we can see it leaving traces of wherever it goes as it's moving around. And I believe that is the end of example introduction.1, traditional random walk. So I'll do future videos as I get to them. What my plan is to read through the chapter, sort of like make sure I'm understanding what's going on, and then I'll do the example sort of live, but not live. Like I'm not streaming it, but I'll be recording myself as I'm building it. So if I do make mistakes, you'll see that. But you also see me successfully implement it, hopefully. And so with that, I hope that you have a great day, and I'll see you next time. Bye.